In this example, we have prime factorization with variables. It's one of the few times that in algebra, when we add the variables, it's actually going to be, I don't necessarily want to say simpler, but it's going to be very simple when you add the variables to it. It's not as complicated as breaking down a regular composite number. So let's say that we start with something like 75 x cubed y. Prime factorization means that you break the term down into all of its prime numbers. So I'd start with that 75. As I look at 75, 75 is divisible by 5. When I divide it by 5, that takes me to 15. And then 15 can be broken down into 3 and 5. I intentionally went out of order here because I wanted to show that if you don't recognize the first number that divides it and you just pick any old number, that's fine as long as what's outside here is prime. And then when you list your prime numbers, you would say something like 3 times 5 times 5. So you would order it from least to greatest. And then as I mentioned a moment ago, with variables, it's actually pretty simple. I just see that there's 3 x's here. So it's x times x times x, y. That's a prime factorization for a monomial. Example 2. Let's say we had something like 132 a cubed b squared. So again, I start with my coefficient, number in front of the variables, and I want to prime factor it. Because it's even, I recognize that I could divide by 2. As I take 132 and I divide by 2, it takes me to 66. Then 66 I recognize as an even number again, so I could divide by 2. It takes me to 33. Now 33, the factors of that would be 3 and 11. I recognize 11 and 3 as prime numbers, so that means I've done all the prime factorization. Everything outside the division box is a prime number. And so I could list this as 2 times 2 times 3 times 11. When I move to the variables, I can go A. And for the B's, it would be B. This is considered the prime factorization. I listed out all the prime numbers that created the 132 a cubed b squared.